Kamakoti sets inspirational targets before us. Last year he set a target of 1 patent a day to be granted actually, and our institute has this year achieved that target, both in terms of filing as well as grants. We have had 366 grants this last year. Now, building upon that, Professor Kamakoti has been telling all of us now that our target is to churn out 100 deep tech, impactful startups every year. This is not an easy target. We have all been very scared. He has even given us a deadline. 25th November 2025, he says he's going to announce that 20% of our graduating class are all CXOs in startups. And that's the target we are working towards. Now, being a visionary, he also, he says, and we also agree that this kind of target is not going to happen if young people are not inspired enough to see that entrepreneurship is a career path that they too can take up. So that's the reason why we wanted to popularize the notion of entrepreneurship, and we want to celebrate the the success and achievements of our our startup stars. So one of the most inspiring examples in this case is AgniKul, represented here by Professor Satya Chakravarthy, Ms. Uma, and also we'll have Ms. Saraniya from the team joining in. Professor Satya is one of our most down-to-earth, yet one of our most brilliant professors. He was also a professor when I was a student at IIT Madras. He's just joined at that time. And he instilled a sense of hope and dream in many of my generation as such. And after he took up the startup journey as well, he has created this inspirational record. And I must say, place this on record for all of you. Right? When AgniKul was founded a few years ago, and when he was talking about being able to send 3D printed rockets into space, it was creating dismay not just among the tech community, but also the investor community, right? So you're going to do this, you're going to raise funds from the capital market, and you're going to put a rocket into space for what joy? And how are you going to ensure returns for the shareholders and going to ensure returns for the investors? So to be able to take a problem that is technologically very deep, but at the same time, to be able to make it into a revenue making and successful startup is a huge skill. It's a huge talent. And that is what AgniKul is managing to accomplish. They have extraordinary targets in terms of how they're going to monetize this technology as they go forward. But before that, we have to celebrate the fact that they have launched the world's first 3D printing rocket ever. To put that in context, a few years ago, we had done a structural analysis of a 3D printed titanium sheet, and we found tons of defects in it. And I cannot believe that a 3D printed component can be a structural element in anything. And to be able to make a rocket out of it, which will not fail at its launch, to be able to perform its mission is no mean feat. I've seen they have integrated inspection as well as in quality control into their work. How many of you here have been to AgniKul office in this research park? Only about 10% of this audience. I encourage each of you to go. You will be transported to the future of where our country can be. Everybody who has been here has gone inspired, whether it's ministers, foreign dignitaries, whether it is ambassadors, scientists, technologists, everybody has gone away deeply moved and inspired that we can do something like this from this ecosystem. And I mean that because I know how hard it is to raise funds in this country, how hard it is to be able to assemble a team that can be motivated and inspired. Hiring has become a major challenge in the startup world. It's extremely difficult to retain talent if we cannot pay them the top dollar. Professor, by his personal example, has inspired, moved, retained this team, and also generated this kind of funding that is required to achieve this. I would say still we are far behind in terms of the kind of funds that we can raise. A SpaceX, the kind of funding that they can raise, we still are not able to do this kind of research, but this is the starting point, and Professor Satya has shown us the way. Thank you so much, sir, for being with us. And all of you young people here, those of you who have not decided to start up, today you're going to change your mind. This is going to be the phase transformation moment in your 4-year or 5-year career journey, and I'm sure about that. thank you so much. Welcome to this event. Thank you for being here. And we kickstart this event with this. Thank you.
Thank you for the word, sir. I'm sure with dedication we'll be able to achieve the targets set by the institute. Now, going ahead, we'd like to speak a few words about our own team. So I'd like to invite Aryan, one of our team heads, to the stage to speak a few words about our team.
Good evening, sir. Good evening, ma'am. Good evening, everyone. So I am Aryan. I am currently the co-lead of Team Abhyuday along with Balaji. We are Team Abhyuday, the rocketry team of IIT Madras. So what do? We build sounding rockets specifically right, as of now for the competition Spaceport America Cup. So as of now, we have flown our rocket 2 times, once in 2023 and once in 2024. 2023 was the first time that we flew, and we got a rank 16th rank in the Barrowman category for our flight performance. This was out of 160 teams that participated. This year has been better. So the Chetak 2.0 that you can see is the rocket that flew. We recover our rockets, yes. So this year in the competition, we were termed as Asia's best rocketry team. And overall, we got a rank 20 out of 120 teams in the competition. So yeah, I'd like to show the launch footage if possible.
You are going in 5, 4, 3, 2, 1. Lift off! Lift off!
They're off. That's a great boost.
Great tracking. Hope you can hear those team cheers. They are excited.
That was an arrow.
So along with that, the competition is not all that we target for. We have also developed India's first student-built hybrid rocket engine. So as of now, we've done 15 static fire tests. This is more of a technology demonstrator where we have demonstrated that the control over hybrid engines, and we are in the process of scaling it up to launch India's first hybrid rocket, student-built hybrid rocket engine. So these are some static fire footage we had last month. Yeah, so we would like to thank C5 for the facilities they provide and also the mentors, especially Professor P.A. Ramakrishna, who has been mentoring the hybrid program, and Professor Anuj Kumar Tiwari, who is also our FACAD, to mentor our control systems program. I'd like to hand over the mic to Arvind to speak about inbound.
Yeah, hi, I'm Arvind. I'm co-founder of Inbound Aerospace. We are an IIT Madras Nirman pre-incubated startup. We are developing recoverable satellites which could facilitate customers to do zero gravity experiments in space, manufacturing or in-orbit testing of technologies. So this enables us to take advantage of unique environment of microgravity or zero gravity and make unique innovative products and bring them back. So we are doing that. We're not solving the launch problem. We could go in a rocket, maybe AgniKul's rocket or any of the available launch vehicle, and then the on-orbit phase and the return is what we are doing. So for any of them who are interested and want to join, watch out for the call for interns that will be sent shortly. Coming to the panel discussion, I'm truly honored to be co-hosting this event with my PhD advisor, Professor Satya Chakravarthy, who inspired me to actually take up entrepreneurship. He is the most influential person in my life. I'll personally cherish this moment, and let's welcome the rockstar professor of IIT Madras.
Thank you, Arvind. Thank you for the words. Now, we'll be inviting Professor Satya Chakravarthy to share his interests and opinions with us. And this is the moment we've all been waiting for. To introduce roughly, Professor Satya Chakravarthy has been a co-founder of some of the most prominent deep tech startups of IIT Madras, which includes Galaxy I, AgniKul, and ePlane. So, I would like to hand over the mic to Professor Satya Chakravarthy now.
Hello everyone. Thanks for having me here. It's very interesting to be at CFI. I'm not new to CFI at all. I've been at CFI looking at what's going on for quite some time since its inception, when you didn't have such a beautiful building before. I think one of the teams that I advise at CFI is Avishkar Hyperloop. So I've been involved in the CFI process in some sense. Also had opportunities to informally advise some student teams that would either want to join CFI or not, and all of those kinds of things. So been very involved in the CFI process in peripherally, or at least if not directly. So glad to be here, first of all. Second, thanks for calling me, and thanks for appreciating AgniKul for what we have done. So I thought I'll actually talk a little bit about to give you a sense of what has happened at AgniKul. At AgniKul, we decided that we will actually make rockets that go to space, to put it very simply. Our initial product that we are actually trying to look at will be in the 100 to 300 kg kind of payload class, going to low Earth orbits in the 500 to 600 kilometer kind of distances, mostly polar orbits. Some of the missions could actually require equatorial orbits and so on. So this is our primary target. And I think as Prabhu was talking about, the whole thing has been configured in a very interesting manner. When we started, of course, we had to do a bunch of configuration studies. We had to do at least about some 50 different configuration studies to find out like what could be the different combinations of solid or liquid stages, and how many of them should be there, what should be the strap-ons, and all of those kinds of things. So we did about some 50, how many stages, right, and so on. So we did about some 50 plus studies, configurations, and then zeroed in on a particular configuration to go with. Of course, at that stage, we think that it's not exactly a frozen configuration, but we will have a target configuration, right, to work on. So from there, it was actually very, very interesting. So at NCCRD, which I have been working on, we have been doing 3D printed combustion chambers for GE's gas turbine engines, for example. Some of the pioneering work in the world happening over there that gave us a lot of confidence that we should actually be in a position to do 3D printed combustors. Sure enough, I think other rocket companies around the world at the startup stage, 150 kg payload class, 300 kg payload class kind of rockets that were coming up around the world, typically in the US. We're also talking about 3D printed engines. And that's when we said, let's actually take a shot at this and push the envelope on what's the best we can do with this particular technology. Now, while we were wanting to do that, the question that we have to ask is, why do I have to actually do a particular technology at all? If, for example, an extremely glorified Diwali rocket could actually take a payload to space, sure, why not? Why should it be a 3D printed rocket, right? So one of the things that I learned early on in entrepreneurship is never try to celebrate a technology unless it is actually going to be useful for a business case. It has to be backed by a business case that requires that technology. Otherwise, you are actually doing some technology just for the sake of it, and you can be proud about it, but nobody will care about it. That's something that we have to always ask. In fact, one of the two words that always has to haunt us if you are doing entrepreneurship in particular, or if you're meaning to do anything impactful in life to the society, or who cares? You have to ask this question, who cares about me? Who cares about what I do? Who cares about what I'm thinking about doing? And so on. So this is actually a question that needs to haunt you all the time throughout your life. Because many times, if you're a student, you're actually coming up to this point where somebody else has actually been caring about you all the time. Your parents are caring about you, your teachers are caring about you, and so on. And that's not important at all. You have to actually ask the question, who cares about me anymore, right? From now on, who cares about what I do, and so on. So our question was, why would I do 3D printing? So we had a very specific answer. AgniKul actually had a tagline, launch anywhere, anytime, affordably. And unfortunately for AgniKul's co-founders, they had actually got stuck with me, and they didn't realize that I'm going to be a very demanding guy, and I can take full credit for this, right? I have absolutely no qualms about doing this at all. So I asked them, if you're saying launch anywhere, anytime, affordably, can you quantify these? Because many times it's actually very easy to come up with a tagline. But the question is, what is meant by anywhere? What is meant by anytime? What is meant by affordably? So we actually worked on this right early on. We said, for me to actually be able to launch anywhere, I need to be able to make a rocket that can go on a container truck. And this container truck could actually be parked in a barren piece of land with whatever safety distances that are required for human habitation temporarily. So we've actually even talked to quite a few people around the world, people in Australia, people in Netherlands, and so on, where they have been willing to identify pieces of land where they can temporarily evacuate people to maintain the safety distance to give us the barren piece of land. We were not even asking for power. We said that we can move in a DG set for the power that is required. I just need only barren piece of land. And I'll move in my rocket, I will articulate the rocket vertically, and I'll go launch, and I can vacate the space. So we had this sort of like a Kalyana Mandapam approach to launching, right? We just said, you just show me where I want to launch, I can launch. That's the attitude that we wanted to have. And sure enough, we have to understand where we are sitting in an academic institution. While I'm actually a professor at IIT Madras, I have my linkages with ISRO as well as DRDO. So for a lot of things, we will want to lean on ISRO scientists to go to space, but when it comes to putting a rocket on a container truck and articulating it from the middle of nowhere, ISRO guys are completely clueless. And that's where our position as an IIT Madras faculty was very important, because I also have my DRDO connects. And so when I say connects, it's actually very, very deep-rooted. If you can talk to like the head of the institution, any of these different levels, all the way down to like the lowest level scientists, because many of these scientists actually are our own students, right? And then many of them are actually doing PhD with me, right? So I have this ability to go cut through this hierarchy and then pick up the phone and call and say, hey, we want to know how to actually launch a rocket from a truck. And this is something that I can't ask my ISRO connects, I have to actually ask my DRDO connects. And sure enough, next day, we had a scientist who had just retired exactly doing this for DRDO show up and then say, yeah, we can help you do this. Right? So this is the way we operate. We actually try to use the IIT Madras network in order to actually put people together in making these kinds of projects. That said, that is the anywhere part. But the anytime part is actually where the 3D printing came up. We wanted to actually try to slash launch wait times for our customers. And if we have not used the word customers in a speech within about 10 minutes of the speech, we are not worth being entrepreneurs at all. So customer is actually the most important thing. The customer pain point is what we have to be looking at. And the customer pain point cannot be a hypothesis. You have to talk to customers to validate your hypothesis on what their pain point is, and then attack that pain point and develop technologies that will address that pain point. Otherwise, don't even bother about the technology part at all, right? So the 3D printing actually came in over there, where we say, if I'm able to actually make a rocket in about 2 weeks, once my customer brings the satellite on demand, I will actually cut down the wait time for satellites completely for my customers. This is actually the focus of the mantra. The launch anywhere part is to assuade customers from saying, if you can't bring your satellite to me, I will actually bring my rocket to you, right? And this is the way by which we can make sure that we are always grabbing customers from around the world. So it's all about, technology has to be customer centric. If you're not customer centric, there is no point in doing the technology at all. I'm repeating this for the third time, right? And this is the focus of AgniKul. It's not about, having launched the world's first blah, blah, blah. I could have been the world's 10th. That's actually of no matter to us at all. What matters to us is, are we customer focused? That's something that if you don't ingrain in yourself as a startup, you will completely fail as an entrepreneur. And that's something that I wanted to actually emphasize. I can't emphasize enough. What about the affordably part? So on the affordably part, we said, let's actually say, I'm targeting, let's say 100 kg payload to begin with. How low on the payload can we go and still offer the same price point on a per kg basis for the cost to the customer? And that's when we had this modularity of these 3D printed rockets come into picture. So we have a patent on the 3D printed rocket. We have also filed for a patent on the modularity to the level that we are actually doing for this, so that we will be able to tailor the rocket to meet the customer requirement. And therefore, we found that between 30 kgs to 100 kgs, we can hold about the same price point on a per kg basis. Very flat, low, flat curve that the customer can pay. Never in the world that anybody can actually offer something of that sort. So we are extremely confident that when AgniKul actually goes through its next steps in going to its orbital launch next, and let's say multiple launches a year to prove the technology consistently, which is required to achieve space pedigree in the next couple of years, we will be the cheapest launch vehicle for this particular class of satellites anywhere in the world, and we can just beat the market hollow. Unless you are actually talking something like that, you can check out. You can go to, like, let's say Peter Thiel's 0 to 1 or any of those kinds of so-called startup textbooks, and you will find that you have to actually beat the first thing is that don't have any competition at all, right? Second, if you have a competition, go beat the competition hollow. That's the way you have to configure your technology to be able to actually prevail in the market against all other competitors, for your customers. So this is the way this whole thing is actually structured. Now, coming to the launch that we did on May 30th, there are two parts to it. One, the launch vehicle itself, and that's what actually gets talked about a lot. You know, the world's first most integrated 3D printed rocket, India's first, LOX kerosene, and so on. In fact, if you think about it, the fact that we actually used the LOX kerosene rocket was because of this international customer focus. We should be able to take my rocket. Nobody has actually exported a rocket in the world before. Okay, and then we are talking about like putting a rocket in a shipping container, put it on a ship, and then sail it to Australia or somewhere else, right? Now, this is not really done. If I were to actually use a solid rocket for that, I will actually incur MTCR regime. I can't do that at all, right? So the fact that we had to do liquid rockets was because of the customer use cases that we were having in mind. So so you need to actually start with kind of like a policy. What's your policy for customer satisfaction, and how am my technology going to drill down? So all of these things like LOX kerosene, and the kerosene that we actually did is ATF. That ATF is something that's widely available. So we don't want to actually have that specific grade of kerosene like what other launch vehicles do and so on. We want to be able to actually use what is widely available, that is commercially possible, and so on, commercially available. So it's actually going to bring down the cost. LOX is something that's commercially available. So you try to use commercially available ingredients. Very similarly, the 3D printing that we do is actually with a commercially available 3D printer, right? So you have relativity space that's actually building a 3D printer around a rocket so that they will be able to develop this rocket, right? It's great, but the question is, are you a 3D printer company or are you a rocket company, right? So you get asked these kinds of questions with investors, right? So, and then you have to explain that I have to first make a 3D printer and then I have to make a rocket and then all that stuff. Those guys, so nope, we're not going to invest in you, right? You're too confused. So you have to have a very clean story. And we basically said, we will actually do a commercially 3D printer, take a commercially 3D printer. It's very interesting because we were actually thinking about all these things in 2018. And we had to figure out what will be the largest commercially available 3D printer in 2022 with which I will configure my rocket engine, with which I will configure how many rocket engines I need to actually cluster together in my first stage and position one in the second stage that will take how much payload to orbit, and figure out whether that payload is actually something that the market wants. So there are two things that we are talking about in this place. One, the usual thing that people talk about is a product market fit, right? You have to actually develop a product for which there is a fit in the market. That's something that you have to figure out right in the beginning. But we have a problem in deep tech. We start with just the technology alone, and then we have to configure a product. So first thing that we have to figure out is something called a technology product fit. Can I develop a product with the available technology or the foreseeably available technology, right? That is first. And then you have to start saying, will this product actually have a fit in the market? Only if all these things line up, do I even start? So this clarity is something that we actually had back in 2018, with which we were able to say, let's push the envelope on the most integrated 3D printed rocket ever. Right, and then that's what we launched this last May 30th. Right, all of that stuff, and then we actually have a very, very frugal launch pad. I should say that the launch pad is probably like less than a quarter of this hall. Okay, right? So as frugal as possible. So one of the hallmarks of Indian technology and Indian engineering is the frugality of the technology. It's not about cheap labor. I'm not talking about paying pittance to people and getting things done. That's not what it is. The technology has to be frugal by itself. It should not demand you to spend any money. The choice of your technology should actually be such that it is not. There is no point in developing stuff that will require like a gold membrane or a platinum membrane or, all of those kinds of things. So long as it actually is affordable, right? So the affordability question is something that is super important. If you have to make something coming out of India that is of global standards. The global standards question is of actually absolutely it's a no-brainer for someone in aerospace, right? G equals 9.81, no matter whether you're actually launching from Sriharikota or from Cape Canaveral, right? So we have to beat Earth's gravity to go to orbit, and we can't stint on any quality as far as the technology itself is concerned. But how do I actually get my tech stack that will make it affordable as a technology itself? The ingredient in the technology should make it extremely affordable. So the first privately developed launchpad specifically for this purpose from Sriharikota, all those records. So we actually had like a bunch of records that were lined up in terms of like, first control launch and all those, lots of these things. To the effect, ultimately basically saying, if we crack this, we are on our way to actually doing the orbital launch, because a huge number of technology stacks have been proven with this particular launch. And getting it right the first time is something that's not so easy, right? There are very few launches in the world that have actually, succeeded in the first attempt. Now, when we say first attempt, that takes to the second part of the story. One is actually what is the product. The second is actually the process. So what we were actually focusing on, Saraniya and Uma, right? And Uma probably was actually firing a bunch of these 3D printed rockets in Tayur consistently, maybe 30, 40 times, right? So she would probably do this in her sleep and in her dreams, right? But firing your own static testing rocket in your own backyard is one thing. Going and launching a rocket is actually completely different. So while the AgniKul team, as of March 20th of March, was very good at actually developing a rocket and putting it on the pad for it to launch, we suddenly realized that, wait a minute, we have not actually figured out how to launch it. This is the Abhimanyu question in Mahabharata, right? So it was actually staring on our face that we have actually not exactly figured out how exactly go through the launch sequence, the launch countdown, all of that stuff. That took some perfection to happen. So while we did a few attempts at launching, the launch vehicle did not move out of the launch pad at all, right? In fact, when the launch vehicle actually got out of the launch pad, it was a great relief to see that launch pad vacant for us. That launch vehicle was not wanting to move out of that launch pad at all for nearly 2 months. And we were trying heaven and earth to get it off the ground. But when it did, it succeeded. So in its first maiden flight, this particular launch vehicle succeeded. That's actually a great feather in the cap for us. Not very, very less talked about accomplishment by AgniKul. That's what I would actually celebrate a lot more than anything else, right, among all of these things. Thank you so much.
Firstly, to begin with, congratulations to you, sir, and the entire team for IIT Madras being ranked an RF1 overall for the 6th consecutive year. Now, I would like to request you to have a few words with us.
So I must congratulate the students. I have not done anything, but just kept smiling. And I think it all worked. Thanks to all of you. I think give a round of applause to all of you for this. Friends, this is a phenomenal success. And I must place on record my deep sense of appreciation and gratitude to Professor Satya Chakravarthy for actually mentoring these kids till they are all children to go to this Himalayan success. To stop a launch 90 seconds before it is to happen in an organization like ISRO or, NASA will require 23 years of experience. Uma has done with just 18 months, right, of your stay, or how much time in? 18 to 24 months. That is the power entrepreneurship gives you. All of you realized? You must clap for this if you really want to be an entrepreneur. It's a unique experience which you'll never get anywhere. That's why I repeatedly say that if you are a failed entrepreneur, if you are a successful entrepreneur, you need not submit your biodata to anyone. But if you are a failed entrepreneur, it's a most credible statement in your biodata. Friends, this particular, I have a small statistics I thought Satya will tell, but he reserved it for me. We need 100,000 satellites in the next 5 years, and the average life of a satellite can be as big as long as 5 years. So every 5 years time period, we will be launching 100,000 satellites, meaning every year 20,000 satellites. So every working day, how much? Let us assume 200 working days, 100 satellites per every working day. So how many per hour? Approximate 4 satellites per hour. So what's the time duration per satellite? 15, every 15 minutes one satellite has to go. And for each satellite, depending on the weight, we need 4 to 8 rocket engines. So how many rocket engines you need to produce per every 15 minutes? Understood? Understood the problem? And if you are going to do the conventional way, and we are looking at this 350 kilometer low Earth orbit satellites. And if you do the conventional way, you require 3 months to do this satellite, and then there will be at least 3,000 soldering points, and then all these have to be soldered. The cost that involved to actually have that precision soldering and then testing it, friends, rocket engine that will take 3 months is now done at 72 hours. And that's the phenomenal achievement which our kids have got. That essentially means we will be probably, and we have the patent for it, and we must put the best lawyers in the world to see if somebody is infringing, so that you get that money, and we do have equity, correct? And once, this is probably, or this is the only solution to handle low Earth orbit rapid launch. We may launch on demand. I need, next 1 month I want a launch to be done. This will be the launch on demand. We can't do it with any carrier vehicle today. This will be the only solution. And that is perhaps the reason why we can bring down the cost from 27,000 USD per kg, which the great Elon Musk is asking, to 8,000 USD per kg. Right? And once we achieve, I think there's no doubt that we will be having the Elon Musk here. Many Elon Musk will come. And that is what today everybody says, MIT #1, this thing. Damn it, yaar, come on. One day we will be known for that perception. One such invention will take us to sky high, and sky is no more our limit. Correct? So, friends, this is where we are pitching startup Shatam. We want every day more than one patent is born in our institute. I am sure every third day we want one startup to come up, and a successful startup to come up. This particular building is dedicated for that. We have the Nirman, we have the GDC, we have incubators, all will work in perfect synergy to see that these startups are nurtured well and you all become successful. This 80% of the 20% of the startup will grow 80%. This is all story for outside, not for NIR of one institution, IIT Madras. I think we need to change it. We will change it. 2018, when I became Associate Dean, along with my boss, Professor Gettu, we were talking about patent a day. And everybody said it's a foolish idea, except we two. And Gettu supported me. And we started telling this again and again, like a mad fellow, I've been telling. Then when I became director, people were forced to listen. Before that, when I start talking, people, I know, face change, array, this guy is blabbering. But I became a director, even when I blabber, sometimes you're forced to listen. Okay. But last year, we did 382. I was saying 366 because last year was a leap year, meaning last financial year at February 29, 2024. At 366, we made 382. This year, the entire IP team met me and said, sir, why don't you announce 2 patents a day? Okay. So we are very confident. They are moving so fast that there were days that when we went to the department and we were saying there's something called patent, which is spelling P-A-T-E-N-T. You all come, it's very protection of ideas. We will do within 72 hours. We'll ensure that your idea is protected. Then you can go and publish. All these things we started. But today, there's a queue there. So they are asking for another 3 or 4 more patent experts to handle this. So that's the change. That's the revolution we have brought. I think the same must happen for startup Shatam. I need to see everywhere some drone flying here, some cart moving here, some robo going there, some cutting happening here. Everywhere in this campus, we need to see some new activity. Otherwise, kya josh here? Boys, by showing a 1.5 crore job in some Google, you'll never get a girlfriend. You show a CTO card or shoot. Okay? So that is the Josh, that's the change that we can. And if Startup 100 is not going to come in next 2 years, 1.5 years, I think that will be a failure for my directorship. We must work for it. We must push for it. Otherwise, there's no Josh. We are also another institution, coming in, going out, doing some job, studying for some assignment. Student cribbing about teacher, teacher cribbing about student. What else? We should change all these things. So, and I am seeing that change. Every day, almost 9 o'clock when I just try to get into my car, some student comes, they say, sir, I am here, I am trying to do this innovation. Okay. At least students who meet me feel that I will be happy if they talk about innovation. I think that itself is a big change. And I want to see that change in every one of you. And we will support all these things. I will personally fight with your instructor if they don't give you permission for going for a competition. All these things are assured. What, Prabhu? Right? We'll ask them to give you leave so that you can go. Innovation is highest in our agenda. We must become employers. November 1, 2025, I must announce that 20% of the graduating class, already CXOs, CTOs, they are ready to give jobs rather than taking your job. If we do that, I think we make a mark, not only in India, but across the world, that this is the way an higher education institution must aspire. Friends, we have 1.5 million people writing JEE mains. All of them want to become engineers. We are taking some 1,200 people in IIT Madras. 1,200 people, if they become employers, in their batch, they will have more than 1,000 people to employ. So, if we don't become employers, who else? Go and look at Krishna Chokula block. Aerospace, today's 7th choice in that list. First is computer science, next is data science. 7th or 8th choice in the list, his department. But he did aerospace MTech here. He continued in aerospace. Today he has given some 0.1% of his wealth, which was 228 crores. What? 0.1% of his wealth. Why I am saying this is not just for money. Prosperity comes from entrepreneurship. Right? Why are you going for a 1.5 crore high frequency trading or this consultancy job? Why are you going for money? No, you get more money. But wait for some time. Perseverance. We are here to help you. We will get you attendance. We will get you anything. But innovate. Let us become entrepreneurs. Let us host startups. We will be conducting one of India's largest fair called Inventive. This happened in IIT Delhi 2 years before, IIT Hyderabad last year. This year we are going to do. I want very successful startups to come as a part of Inventive. We will show what IIT Madras means, what a higher education institution should mean to the world. I think we must do. And I'll keep repeating this like a madman till we reach this 100 startup Shatam century. Then we'll think about startup 1,000 and more, 10x. It's not a dream, it will become a reality. So friends, will you all do it? Yes, no? Are yes? Big yes, yeah. Tea or not? This hall is known for its echo. Yes? Thank you.
Thank you, sir. Now we'll go ahead with the panel discussion.
Hi, I will get going with the panel discussion. First, how did it actually happen in IIT Madras? I think that you did not explain when you give the talk. How did the IIT Madras connection, because Srinath and Mohan are not from IIT, so how did that happen? If you can explain.
I guess that's a question for me. So, first of all, I do not discriminate between IIT Madras and outside, personally. I think Kama would support me as well on that one. We are very conscious that we are part of a larger whole, which is India. So everybody who is an Indian citizen is somebody that IIT Madras should serve. That's actually the basis. And the way I personally look at things is, if somebody has interest to do something, we have to encourage it. We don't have to worry about whether they're capable of doing or not. The interest will actually propel them to learn themselves to become capable. That's actually more important. So I have actually been teaching space tech in my classes for a long time. If any of you were to take my class, you would know that I would freely give out ideas for anybody to implement. And in fact, I would specifically say, this is a startup idea. And this has happened for several generations of students, and nobody would pick it up. So here I am with like a bunch of ideas that you can do. And there is like a couple of guys who just walk into my office and say they want to make a rocket. I said, sure, why not? We have like plenty of ideas that we can employ. And it's important for us to understand what an academic institution can do in deep tech. We are, after all, actually developing a very small rocket when compared to what an ISRO or a SpaceX is doing. And that's exactly where we can innovate a lot. And when you're now targeting, so the only thing that you have to worry about is, does that small rocket actually have a market? Right? Do we have customers for that small rocket? The moment you actually are satisfied that you're targeting a problem that is of a good market size, that it's worth all your sweat and blood, right? Then go for it from an academic institution, because an academic institution can actually support a small high-tech product much more easily when compared to a lot of other big organizations. In fact, I have, representing AgniKul, I actually visited as part of a FICCI delegation, the French Ariane group, okay? And just when I was visiting, this was March 2018, what we found was they had a micro launcher program called CUTS, and they had actually shelved it because they were focusing on the Ariane 6. Right? It is actually so creditable that ISRO could actually pursue their SSLV program to completion, which happened like last week, when they were also actually doing lots of other things like the Gaganyaan or the Mangalyaan or the Chandrayaan and all that stuff. It's not so easy for an organization to be nimble to be able to do big and small stuff at the same time. In fact, I remember in 2018, I was at the AAA Aviation Forum, where the Boeing CEO was actually participating in a fireside chat. And he was saying that Boeing is a 103-year-old organization, and unfortunately for them, they have to think like a 100-year-old organization as well as a 3-year-old organization at the same time. So these are changing times where you will have to be very nimble to figure out what you want to do. And that is possible in an academic institution. This is something that we have to clearly understand, as opposed to thinking that making a rocket is somebody else's job. No, we can actually do these things here.
Continuation on that. So AgniKul is doing something that no one has done so far, 3D printing a single engine, like a single piece 3D printed engine. So what was that motivation behind not going with the industry proven conventional methods and choosing something that no one has tried, something that's very risky?
Yeah, 3D printing, as we all know, it is simpler. No, I would say time-wise. Definitely not simpler in the first time. When we started off with 3D printing, we did lot of iteration to come up with a particular configuration. So our engines is designed for 3D printing. That is designed for manufacturing. I think when we were in NCCRD, we were doing this plastic 3D printing injectors first and all those. Definitely, as Kamakoti sir also correctly said, instead of spending 3 months, we can print one engine in 72 hours. That is all it takes to build one engine now. Yeah, that is the motivation, to reduce the time.
So one more thing that comes into my mind when I look into a single piece 3D printed rocket engine is the inspection and repairability is a very big concern now, because, and in a sense, like a very small part, let's say a part of the injector gets damaged. And in a modular ways or a conventional method, you could replace a particular injector and you can use the same engine. But how do AgniKul deal with these kinds of issues?
Yeah, so from the beginning, that question was there, whether how to know whether there's going to be some damage or defect. So we have a rigorous process from the start of manufacturing till we get to the point of firing or testing. After it manufactured, we will have we have multiple processes in place to make sure after every after printing, there are multiple post-processing phases. So at every phase, end of every phase, there is a check. We make sure the parameters or we have points to inspect. So it meets the parameters, and then, for example, after printing, we follow a process called depowdering. After depowdering, we make sure there is no powder trapped through a CT scanning process. So like that, we have process to ensure after end of every process, the hardware is good. Similarly, after every testing, every hot fire test that we perform, we make sure dimensionally things are okay, and we also perform post hot fire cold flows, post hot fire tests to ensure the hardware is intact. We will have data to match the data we had before the firing, before the testing. So certain processes like that will help us.
And what about the repairability? Is there a way we can salvage the same engine, or do we need to move? I mean, it does make sense to move on to a new engine as the time taken will be very less, but still, is there repairability somewhere in this?
I think it is easier for us to print another one than to repair.
So you mentioned about the SSLV. Was that surprising to you from company point of view that they're also in the same market of AgniKul? So your thoughts about the SSLV and how does it compare with AgniKul's launch vehicle?
Actually, to be honest with you, even Skyroot was a surprise to us. Right? So I think Srinath, the CEO of AgniKul, was quite convinced about the market demand for sub 100 kg satellites, that we were on our way. And one of the investors who was actually interested in investing in us told us that he has also evaluated a competitor of ours. And we were like, who is that? Okay. So I think to some extent, if you are sure about what you want to do, you can just go ahead and do it. But you might want to pivot if the circumstances require you to do so. We didn't really look at SSLV as a threat at all, because it was in the 300 to 700 kg class, whereas we were sub 100. We had a clear Venn diagram of lack of intersection and then there was a market. So we actually have histograms for what's the demand for satellites. Whatever Kamakoti says, right? There are 100,000 satellites. We have a clear histogram of those demand. Like how many of those are actually in the less than 100 kg class? Where are the peaks in the histogram, and so on? So there's like a 20 kg peak, there's a 80 kg peak, there's a 125 kg peak, and all of those kinds of things, right? So we actually have market trends, and we can figure out like where we can carve out our own market share and all of this stuff. So never been really bothered about SSLV or Skyroot, as a matter of fact.
Okay. Talking about the launching aspect that you said, so you actually had to go through multiple holds. How did the team, how did you as the leader kept motivated them?
Actually, I would say the team was very, very motivating. More than me or Saraniya motivating the team, we have had testing before. We have also performed tests where we went home disappointed that day, some things don't work and all that. But more than that, the team was, I think Saraniya would also agree with me on that. If there was a hold that day, we will have a series of meetings after that to get the clearance for the next launch. So that even if we both feel like, okay, now we'll have to get those meetings done, the team will come up with strategies, team will come up with ideas to get the meeting done. They will propose ways to how fast we can get that done. So I think team was very motivating. That is my point. Saraniya can tell hers.
Yeah, completely agree with Uma. We had a very enthusiastic team with us. So after every launch hold, whenever we go for the next launch attempt, then every time the team was, even though they have worked for like 24 hours, 48 hours continuously, there was never a no. We all knew that we are here for one purpose. We all worked towards that. We knew that we are here for launching. And I think the whole team also echoed with us. Yeah, that is what kept us going.
Just a normal question, like general question. How was the excitement when you guys saw the first launch happening? Like, I've seen the video, I can see everyone being very happy, but what was the inner feelings of that?
For me, I mean, very relieved, like sir told, we all had a sense of relief after the number of days we had put in, and then the number of times we had to hold, and then given the circumstance we were all in, it was a relief. For me, I was looking at the vehicle like right before T0, the liftoff moment. I was able to see the vehicle, and just after liftoff, just after T0 liftoff point, when I looked, like for an instant, I got a chance to look at the CCTV, the camera on the data feed. The vehicle was not there, so there was a feeling of missing something, you know. We all immediately rushed towards seeing the telemetry data, because the moment vehicle lifts off from the pad, we lose the vehicle, the data that is coming through the ground system, and then we'll have to rely on the telemetry data for the parameters, for the data from the vehicle. So we all rushed towards the telemetry side, and then I actually could not. I mean, we didn't know where to look for, what to look for in the telemetry data, and then we were all scrambling for some time, and then so that's the feeling I had. The team was very excited. With all the excitement, the feeling of missing something was also there for me.
So now you know why you need to have an automated launch sequence and a onboard computer to take all the decisions, because we are scrambling for data. Looking at the data, that's not going to work.
Yeah, I think it's same. It's whenever we are inside the mission control room, it's so much pressure when the countdown starts, when T-15, when it goes to the automatic launch sequence. That too, when we had already an abort for last 4 times. This was the 5th attempt which we were doing. It was always a fear that will it hold again? Because we had done till T-11 second, the last hold was there. So it has to cross that T minus 11 to 0 this time. So every second was, I could not sit. Like, if you can see in the videos, I'm always standing because it's so much pressure inside that mission control room. As soon as it lifted off, and the way it lifted off, the way we wanted it to actually. So that was such a relieving and the most happiest moment. I think everyone in the team there were shouting, dancing. I even heard people outside shouting because some few team members were inside the mission control room and few were outside. And it was also from outside also people started shouting because they could see the vehicle. So every time we see GSLV, PSLV, whenever some launch happens, in our Tayur campus, we'll go outside and we'll see. Generally GSLV will be able to see clearly from there. So similarly, this time also when they shouted, I ran outside and I saw our vehicle actually flying in the vehicle. It was our vehicle this time. So yeah, that is the moment, that is the memory I have of that launch.
Now, looking forward, what are the immediate next steps for AgniKul? The next few steps, and then where do you think this market is actually going? Like, because as I understand that Rocket Lab is also developing a larger rocket. Agnilet is also developing larger rockets. Does AgniKul have plans for a larger rocket, or what are the next steps?
Yeah, I mean, our immediate next major step would actually be orbital launch. And there are multiple smaller steps towards that. We have to qualify our engines and so on, stage separation. A few such steps are lined up, right? And this is expected to actually keep us busy in the next few months progressively. I think Uma is in the middle of actually an engine firing today, and she had to take a break and come, and I was like, why didn't you send somebody else? Right? So yeah, so it's daily work for us today. But going forward, our goal is not exactly necessarily going to bigger and bigger vehicles as such. We'll have to have a dipstick on the market. Right? We have a sense of what is the growth of the market size that we are trying to capture, right? Which is the, let's say, 100 to 300 kg or even below. So it'll be interesting for us to see. In fact, my gut feeling is when AgniKul actually happens, it will open up a lot of the small satellite market. Currently, the small satellite market is held up because of the wait time problem that they have to go through. And investors actually not investing in small satellites because they have to go through a wait time. But if your AgniKul opens up, then small satellites will actually be able to launch on demand. And of course, the demand could surge and then we may not be able to meet the demand. So we'll have to actually do market corrections for those, all of those things. But let's say we are able to actually calibrate ourselves to the market demand. That will actually spur more demand. And this, because it's easier for people to make smaller satellites when compared to larger satellites. But the margins could actually be more with the larger satellites, right? So one of the reasons why the Western companies would actually go for larger satellites is simply because they are way too expensive. And if they have to justify their return on investment, they have to go towards larger. They're compelled to do so, right? So, or put it another way, they don't have a product market fit in the small satellite segment. That's the problem. So we have to actually call out these things that the Western guys are doing, and this is where Indians should actually think on their own, based on first principles of what is exactly the market looking like, right? Instead of just blindly following, okay, that guy in the West has actually done this guy in the West has done that. No, yeah, they have a problem. Right? They are too expensive, right? They don't belong on this planet at all, actually. Okay. Why? So in fact, people ask me the question, how is it possible for AgniKul to raise only so much money and then achieve so much? How is it possible for E-Plane to raise only so much money and achieve so much? Right? Why are you guys so cheap? My answer, I'm just blunt now. You ask those guys who are actually so expensive, why they're expensive. Don't ask me why I'm actually cheaper. Right? I'm doing the right thing. I don't have to actually explain this to anybody else. So we have a better chance of fitting to the market much better And we will do what it takes to actually do that instead of saying that I actually go larger or smaller and all that stuff. Left to myself, I'm not the guy who makes the decisions at AgniKul, right? But if I were to, I will say, yeah, I mean, I want to actually start launching from like 1 kg onwards all the way to 1000 kgs at the same flat cost curve, right? Low cost curve. That is the ability that we would like to have. Another matter of fact, we actually have that ability, right? Whether we will go and execute it is a question of market response.
Any studies or direction towards the reusability of the rockets?
Yeah. Quick answer is yes. No more details.
I think from your perspective of AgniKul, how did this actually impact the overall Indian aerospace ecosystem? Like the success story of AgniKul impacted the overall ecosystem?
I think it definitely motivates a lot of young people, right? I think Prabhu was telling me that we were a good crowd puller. The previous startup Shatam event did not actually attract so much crowd. So if there are so many eyeballs that are actually listening, watching this, and pair of ears that are listening to this, we hope that we actually motivate people with what we are doing. I think one of the problems that I sense about India is we don't have this conviction that we can do things. And so we actually, internally, we call it the brown curse. If we are able to demonstrate these kinds of things over here, that can spur a lot more innovation that our director wants, and that's really the hope. It's actually a lot more intangible rather than, I mean, another way of actually trying to tangibly put it is like, by 2027, how much of the GDP contribution we will make and all those kinds of things. We can do those kinds of things. We have done those things, but that's actually much more tangible and sort of heuristic. But more important is to capture the mind space of youngsters. And I think that's hopefully something that we are working on. Yeah.
I think we can have an audience ask few questions. Yeah, I see your hand raised.
Hello. Hello, sir. Hello, ma'am. I'm Supan, and I was actually leading the 3D printing club of IIT Madras of CFI. So I'm really intrigued by the fact that like 3D printed products or anything 3D printed is like a little bit anisotropic. So how did you deal with the simulation part of that? Because like rocket and normal materialistic properties were available online before itself. So how did you deal with that? And plus one more thing about the like the finement or the granule part of 3D printed parts, because they are not much smoother as the normal printed parts. So can you just...
Yeah, to answer to that, generally when we print the engine, right? So there is a build plate. In the build plate itself, we will be printing coupons for it. So both in the horizontal direction as well as the vertical direction, so that we get the properties in same build plate itself. We'll understand what is the property. Every engine which we print has at least 6 samples in it. We every time test it. Then we use that for our simulations. And we do a thorough simulation from the structural to the thermostructural. Everything is done. It also goes to the plastic states and all those things we study thoroughly. And then we get the test data, like we have thermocouples. Then we compare our results with our analysis. And then we say that it is okay. Secondly, to answer, yes, it is not a very smooth surface which we get out of engine printed, right? So that actually helps us because more surface area because of the granularity. And we have a regenerative cooling inside the engine, right? Nowadays every engine has it for cooling your chamber.
Yeah.
So more area, more cooling it gets for our engine. So that is how it helps us actually.
And about the fuel part, like does anything affects the flow of fluid
No.
because of granule part? No.
No, nothing.
Thank you.
So given that you have a team of 3, and you have 3 founders, and you are raising, given that you are 3 founders and you're raising multiple rounds, how do you handle dilution while you're raising large amount of money?
Oh, that's a sad story. right? So I feel maybe because I'm old, maybe because I'm a prof, my mindset is very different when compared to maybe if you're like young, fresh out of college. So when you're actually, so you look at typically a lot of these e-commerce, SaaS kind of startups that come out of like an IIT Delhi or an IIT Bombay or any of those kinds of places, when compared to like the extremely geeky, nerdy startups that we have out of IIT Madras, that I'm extremely proud of, right? Those fresh out of college guys have this attitude that, you know, I need to be able to control my company, I need to have a significant share of my company and all of those kinds of things. But dude, we are actually doing deep tech, okay? It guzzles a lot of money in the first place, number one. Second, I'm the guy who actually knows in and out of what I'm doing, right? Unless I'm actually having like an Ambani or an Adani walk in to my office and then say, here is hard cash, I'm actually taking over, and it's like a hostile takeover, right? And it becomes like a strategic, investment, where they probably have the wherewithal to put in the management structure to run the company and all of that stuff. The kind of investors that we normally get have no ability to actually take control over the company at all, even if they had more than 50%. So there is this phrase that's very important for startups. Dilution does not kill a company, cash flow does. You want to make sure that you have money with you. You don't care about dilution. At the end of the day, if AgniKul is actually valued more than $1 billion, it doesn't matter whether you hold 30% or whether you hold 50%, right? You are worth a lot of money, right? Than what you could even dream of. But much more than that, you have actually launched a damn rocket, okay? That's much more satisfying than how much money you are worth, right? With how much equity that you hold, all of that stuff. It just doesn't matter, right? So for us, the mission is more important, dilution is less important.
Hello, sir. So I'm Sriharikota. I'm from 3D Printing Club currently. One doubt I had is the material you use for 3D printing is Inconel, if I'm not wrong. So how cost effective is this? Is it like cheaper compared to the current available engines or whatever?
Saraniya. So all technical questions to these ladies, non-technical questions to me.
Sure, sir.
Definitely yes. If you see conventionally made rockets, right, it has somewhere around some 300 parts. And then you have to, especially the regenerative cooling which I was talking about, it is having welds. Every channel is made and it is welded spot by spot. It is like more than some 1,000 welding they do to put all the regenerative coolings in it. I think definitely for us, because our size is smaller, Anjan's size is smaller, it is always better to go with 3D printing because that is also cost effective. All this thing is done by only 3D printer. So no other conventional method we are using, no other extra welding or nothing we have to do. That way it is helpful.
Thank you.
Hello, sir. Actually, success of any startup depends on its manufacturing cost. So, what would be the manufacturing cost of the product? So, based on that, what is the current 3D printed engine cost per unit and lead time? And what is the goal to meet that demand of 100,000 rocket engines in the coming 5 years?
This is not a technical question, is that okay? Fine. So, strictly speaking, everything is relative, okay? So if I have to think about cost, I have to actually think in relative to the price, okay? So what is the price can I command versus what is the cost I'm going to get is actually going to determine my profit margin, all right? So if I'm able to actually get a opportunity cost of being able to launch very repeatedly, all right, reusing and so on. And for a lot of these reasons, I can actually bring down my cost progressively, all right? My margins keep on increasing. So the one interesting question that you could ask, right? Why did I actually choose to work with AgniKul? When I chose to work with AgniKul, I had absolutely no idea about entrepreneurship at all. Okay, so I was a prof. I was teaching rockets. So somebody wanted to make rockets. I was happy to make rockets along with them. And I was still a prof. So nobody would actually question me on, hey, is it a profitable business that you want to be doing or any of that stuff? All that questions actually will be asked to the other founders. Okay. But at some point, I was like, why am I wasting my time with this startup? Does it really make sense economically? So we did a costing. And I was mind blown. So only then I realized why rockets are actually sexy. It's not about the technology, it's actually about the business, right? So why is the business so attractive? Is because our costs are extremely low when compared to the margins we can clock by commanding the price that we can do in the market. That's where the matter is. It's not about the cost at all.
Just a normal question. How much, so Indian market, Indian engineering also depends a lot on a term called jugaad. How much of that influenced AgniKul in a sense? Like,
see, this term jugaad is actually abused. Okay, in aerospace, we just can't do jugaad at all.
Yes.
Right? We have to follow processes. We have to have documentation. We have to show records of what we do. We have to show repeatability, reliability, all of that stuff. So there is just no way by which you can quickly fix something and all that stuff. Nothing of that sort. And these are actually international standards. There is nothing Indian about these at all, right? The jugaad is actually in configuring the startup, not the product, right? The jugaad is actually about how is that's what I told you, right? The technology product fit that has to precede the product market fit. Are you able to actually line up your technology to make a product, and that product doesn't actually have a market fit? If you're able to think through all of these things, we have had a lot of debates that Uma and Saraniya were not part of among the founders on what's the choice of the rocket configuration that we have to have. What's the choice of fuel that we have to have? What's the choice of oxidizer that we have to have? That makes economic sense. And all of these things are actually, in some sense, like an Indian jugaad, right? And in fact, the problem that I see is that the Western aerospace mind actually is intoxicated more with the technology. So aerospace guys basically think, I'm making like a great rocket, right? I am actually something that is, divined upon this humanity. The rest of the people should actually figure out how to use this technology. I won't care too much about the customer. Whereas here, we have very little money, right? We have to be extremely frugal. So we have to figure out how the technology will allow us to be frugal. Those are all the jugaad elements, I would think.
thank you, sir. Thank you for answering all the questions. Thank you, ma'am. I'd like to welcome our director, sir, for...
Discussion. So in the presence of Director Professor Satya and Professor Prabhu, Office of Innovation and Entrepreneurship is launching its magazine. First moment. Oh, okay. So we would like to present a memento to Professor Satya. So Team Inbound and Team Abhyuday, both of them have some gift for you, sir. The Office of Innovation and Entrepreneurship is launching its magazine called Innosphere for the first time. This is the first edition, and
Okay, friends, we will have the very first demo day for Nirman, and the date has been fixed. 21st of September, and we are unveiling the logo for the demo day as well. Yeah, you want to say something about the logo?
this is the first demo day after. This is the first demo day that we are doing, and we have more than 90 startups that are going to present. On the September 21st, that's a Saturday, I would like all of you to be here. It's happening at Terrace Hall. We'll have a director, we'll have Prabhu sir and lot more people coming, and we would like you to see all the progress that C5 teams that are currently in Nirman and the Nirman Incubator startups have done, and get the exposure to the startup ecosystem at IIT Madras. I would like to call Madhav for the thank you note now.
We have one more announcement. Professor Kamakoti will like to.
There is one advanced manufacturing tool development center in Research Park headed by mechanical department, professors from mechanical department. So there will be AMTTC day. It will be the next startup Shatam, series. So I want each one of you, so we have around 100, but I want 500. So each one of you bring 4 more people who are not here. Okay? Just take attendance here and bring 4 more, because Industry 5.0, which is going to be the biggest boom, requires a lot of manufacturing. And AMTDC will come and showcase many interesting problems which you guys can take. That's now a robo which can plug oranges. That's part of Industry 5.0. The oranges will be sorted so that it will be good, bad, worse online when it is plugging. Right? So like that, many interesting, very simple, but very simple to define, but very complex to, finally arrive at the solution. So that is something which AMTDC will demonstrate that day. So each one of you, and it will involve at least, how many computer science guys are here? Nil. Oh. So I'll special 10 more marks for these people who bring one computer science guy along with you. Okay? So everyone, please bring 4 more. So that we need, people should stand there, here. That's the spirit, man. That's the spirit we need to bring. Okay? Good luck. So AMTDC day, we'll announce the timing and date. Thank you. Demo day, September 21st. Please do come for this demo day. We'll all be here. And this is hard work done by several startups. Very interesting thing. Just I went up. By the time I came down, at least 4 different domains, one on speech, one on robots, one on hydrogen, and one on the ocean structure, one on medical. I've seen 4 in 5 minutes. I've seen 4 different domains. So you'll see excellent set of teams. So it's also a scope for you. And these teams must also give summer internship. This internship mela and all these other companies coming, our fellows should work for all the knowledge that we generate should be useful to our own startups. So we should also have an internship mela from Nirman, Nandini. So next year internship mela will start with Nirman. Our fellows will give and we'll give certificates, right? So, and we'll give more interesting problems than all those big companies. I think we'll make a very concerted attempt. So 21st September, personal invitation from director on behalf of Nirma and all to be here. And each one of you bring 4 people. Okay, and if you bring a computer science guy, you'll give additional weightage. Thank you.
Thank you. Thank you so much, all of you.
Pleasant evening to you all. First of all, on behalf of CFI and Nirman, I'd like to extend my deepest gratitude to Director Professor Kamakoti for initiating the Startup 100 talk series. We are extremely fortunate to have such a supportive environment at IIT Madras, where the leap from academic learning to entrepreneurship is made in a smoother and in a more available manner. Your unwavering commitment to fostering innovation has truly given us a head start on our entrepreneurial journeys. I'd like to express my heartfelt thanks to Professor Satya Chakravarthy and the AgniKul team, Ms. Maheshwari and Ms. Saraniya Periaswamy, for sharing their incredible journey with us today. Your insights into the challenges and triumphs for building a space tech startup has not only been enlightening, but also have inspired many of us to push boundaries of what we can achieve. A special thanks to Professor Satya Gumadi, Dean students, for gracing this occasion with your presence. I'd also like to thank Professor Prabhu Raj Gopal, Advisor of Innovation and Entrepreneurship, for the unwavering support you have always provided. Your guidance has been a backbone for both CFI and Nirman, and we are forever thankful for the dedication and expertise you bring to our initiatives. A big thank to Team Abhyuday and Inbound Aerospace for their hard work in organizing this event and making it such a success. Your efforts behind these scenes have truly made today possible. Last but certainly not the least, I would like to thank the managerial teams and the Office of Innovation and Entrepreneurship for ensuring the smooth conduct of this event. Thank you all for being here today and for contributing to the success of this event. Your presence and participation are what makes these moments so special and impactful. Thank you.